Okay, so members, today we are going to see how do we handle trig inverse functions. We are going to start with proofs, then we shall go into equations. So, start with, don't forget subscribe to the channel. Now, here they are telling you, show that this is 1, 2, and 3. Show that tan inverse over tan plus sine inverse of 1 over 5 is equal to this. They want you to show that the left hand side is equal to right hand side, which is pi. How do we start? We start by letting off the inverse functions. You let off this, and this off. If I say, let this be A, let this be B, and let this be C, implying that now my AC is tan inverse of a sine, which implies that my tan A is a third. From here, straight away, we draw a right angled triangle so that we can get our sides. So you see, tan is given by opposite, which is 1, over the adjacent, which is 3. So now we start missing this side. What I would say, this is squared, you know, using Pythagoras, you said, this squared plus this squared will be giving us this squared. So because we want the side, we get the squared. So we have 9 plus 1, then they have the square root, will be now root 10. So that's it. Then I come here, so that my b is equal to, implying that root 5. And sine is given by, straight away draw a right angle triangle there for this. Sine is given by opposite, which is 1, over hypotenuse, which is root 5. So that I'm missing this. Well, how do I get this? I get this squared minus this squared and the square root. So this squared is 5 minus 1 squared, which is 1, that is 4, and the square root, this will be a 2. So from here is what we have. Now from here we have A plus B is equal to C. Introduce tan both sides. So we are having now tan A plus tan B equal to tan C. So that is that our C from here, start from there, our C is equal to C over pi. So we want to see what is this equal to. So we simplify now this. You know how we expand this using tan. So this will be tan A, tan B over 1 minus tan A, then tan B is equal to our tan C. But we know that tan C is this. We want to see is our C equal to pi, because from here is that our C is pi over 4. So now we substitute tan A. From here is that our tan A is a third. So here I have a third plus tan B. Here you can get our tan B. This is our A, this is our B, because we are using B here, we are using A. So tan B will be opposite over adjacent, which is a half there. The whole over 1 minus tan A third times a half equal to tan C. From here up we have 2 plus this. We have 5 over 6. We are dividing by, here we have 1 minus 1 over 6 is equal to tan C. So allow me right here. So from here is that my tan C will be 5 over 6 divided by, this will be 6 minus 1 over 6, which will be 5 over 6 over 5 over 6. And from here is that my tan C is equal to 1. I want to get my C. My C will be tan inverse of a 1. So that my C will be 5, and this is pi over 4. So we have proved that our C is equal to, so meaning that now the whole of this tan A, tan B, I mean A plus B is equal to C. So it's that when tan A plus B get C. So there we have proved that. When you come to this, the same idea. We let already inverse, let the whole of this be A and the whole of this be B. We don't include this. We don't include the coefficient, we just let only this. So from here it's that still my A tan inverse of this implying that my tan A is a third. Immediately, we write down the triangle to get the missing side. This is A, so opposite, which is 1, then adjacent is 3. So meaning this is going to be root 10. Then from here, I come now this side, I have B. Now this B is this time tan inverse 1/7, implying that tan B will be 1/7. So there I also write down the triangle. So this is B, opposite is 1, this is 7. Meaning, to get this, I'll get this squared plus 1. So this squared is 49 plus 1, that's 50. Then I'll be having root 50 to get that. So now I have now 2A plus B is equaling to, this one is saying that it be C, is equaling C. Still the same thing, we introduce tan both sides. We want to see that our tan 2A will be equaling to tan C. We want to get C. So now here, we expand this, which will be having tan 2A plus tan B over, this will be 1 minus tan 2A tan B equaling to tan C. But we know that from trig or is our tan 2A is 2 tan A over 1 minus tan squared A. We know this from now angles. So here you can get is that our tan 2A is going to be 2 into tan A. From here our tan A is 1/3. The whole over 1 minus 1/3, the whole square. This will give us 2/3 divided by, this side I have 1/9. So that we have now 9 minus 1/9, which will give me 2/3 divided by, this will be 8/9. If I get the reciprocal, so this will be 2/3 times 9/8. And the whole of this, so this will be 3/4. So meaning that my tan 2A is this. So if I come now, I substitute here and here, I'll be having now 3/4 plus tan B 1/7 over 1 minus 3/4 times tan B, which is 1/7. The whole is equal to tan C. Let us simplify. This will be 21 plus 4, that's 25/28. So up I have 25/28. Then down I have, this will be 3. 1 minus 3/28. This will be equal to my tan C. So if we simplify, I have 25/28 divided by, now this will be 28 minus 3, which will be 25/28. It's equal to tan C. And so that from here, now, so that this divided by this will get 1. So 1 is equal to tan C. So now I'm going to get my C. My C will be tan inverse of 1, which is 45, and this is pi/4. So we have that this, the whole of this is equal to this, and so the answer is there. When you come to this side, this now, so that all this side we have angles. Now this side we have a function. So still this will be A, this will be B, the whole of this, and this will be our C. So from here is that our, if now I do, you see that now I'm going, okay, my A will be cos inverse over 65, implying that cos A is 63/65. Immediately we will write down the triangle there. This is A. This is now adjacent 63/65. And you see, if you simplify now, we shall get this, we shall get this squared minus this squared and the square root. And so that this will give us 16. Then might be, we don't include the 2, we just take this one, tan inverse. 1 over 5, implying that our tan B is here as 1 over 5. Immediately, draw our right angle triangle there. This is B. This is going to be adjacent over, opposite of adjacent. Now, so this one will give us 25 plus this, which will give us root 26. Then, from here, you see that now my C, for it is sine inverse of 3 over 5, implying that now my sine C is equal to 3 over 5. This one we want to prove. So from here it starts my A plus 2B is equal to C. Now because this side I have sine, it's better now to introduce sine without, so that we prove that sine C is equal to this. So this side we introduce sine A plus B equal to sine C. Why am I introducing sine C? Because the side I have sine C already, so that it's easier to introduce sine C both sides, because the value of sine C is this. Now I want to see that the sine C equal to this. Now from here I start sine C will be, now can I expand this? If we expand this, we have sine A, then cos 2B, then plus sine B, then sine B, sine 2B, sine 2B, then cos A. So this will be sine A, from here our sine A, from here I can get sine A. Sine A will be opposite over adjacent. So this will be 16 over 65. Then here, so now from here I use double angles. I know that orange cos 2B is the same as 2 cos squared B minus 1. Why am I doing this? Because I have a single angle. Here I can get cos B as adjacent over hypotenuse, which is root 26. So I have a single angle. That's why here I have a double angle. I remove it like that. So this will be now 2 cos squared B minus 1, then plus sine 2B. You know that sine 2B is the same as 2 sine B cos B. So from there, now I put the same thing here, 2 sine B cos B, then cos A. So can you substitute? This will be 16 over 65 into, now here I have 2 times, now if we square this, we shall be having 25. We square the down thing, we get the square root of that way, and shall be having 26. Then minus the whole of this, minus 1. Then plus 2 into sine B. We have sine B, we can come here, we can get our sine B. Sine B will be opposite over adjacent, it will be root 26. Then times R cos B, we have seen R cos B is here, 5 over root 26. Then R cos A is here, 63 over 65. And that's what we get. This will be 16 over 65 into, this will be 50. 50 minus this, which will be having 50, minus 26 over 26. If you cross multiply, this times this, you get 50, and this times 26 over the whole. Then plus, up we shall be having this times this. You can easily get your current, this is 10 times this, 60, 30. Over, you multiply this times this, will be having 26 now times 65. And the answer will be having is, you get your calculator. From there, you see, here you have 16 over 65 into, now This way we simplify so that we have 24 over 26, then plus 6, 30 over. This will multiply 26 times 65, that is 1690, which will be, let us simplify this, 16 times 24, here we get 384 over, this time this is 1690, then plus this, which is 630 over 1690. So when we add those ones, this is, remember, this is our sign C. When we add those two, we get 1014 over 1690. And if we reduce that one, what we get is 0.6, which is the same as 3 over 5. So we are showing that now our sign C is 3 over 5, which is what we had here. Our sign says that, and there the proof is complete. Since this is equal to this, now the whole of this is equal to sign C we have seen, because our sign C is here. Don't forget to subscribe to the channel. I wish you the best.